All right, this is the AP Stats 4 dash, technically 4-4 notes, because remember I added in a textbook part of the notes. So this is covering geometric distribution and Poisson distribution. So a geometric distribution is a discrete probability distribution, and there's a couple of things that are very important to identify it. The trial is repeated until, there's the key word right there, until you get a success. So where binomial distribution is, you have a success and fail, and the probability is based on success. Each time we expect that there would be a success. This time it's you just keep doing it until you finally hit that successful rate. You've hit it. It is important to remember that they have to be independent of each other, and probability of success is constant for every trial. And then the random X represents the number of trials in which the first success occurs. Okay, so the formula is P times Q raised to the X minus 1. And remember, Q is 1 minus P. So this is really 1 minus P times 1 minus P raised to the X minus 1. On our calculator, menu 65H, we'll get the same thing. You put in your P and your X, and I will show you that here in just a second. So if we assume a probability that you make a sell on any given telephone call is 0.19. So you try to make the call, you have a 19% chance of actually making a sale. We want to find the probability that the first sale is after you've done 5 actual phone calls. So you call, they say no, you call again, they say no, you call again. On the 5th one, that is your success. So P here is saying that anytime you make a call, you have a 19% chance of getting the sale. It takes you 5 tries before you manage to get there. And that is the probability of the 5th call being the success is the success 0.19 times the failure 0.81 raised to the 5 minus 1. 5 is the number of trials that X that it takes you to, minus 1 allowing for error. Okay, so on our calculator, excuse me, menu 65, and then you just type the letter H, and notice it just has 2 blanks to fill in. P, which is the probability of success, and X, which is the number of times it took you to get to a success. And then you hit enter, and you get 0.0817, 0.082. If you're doing it by hand, it's 0.19 times 1 minus 0.19 raised to the what number of successes it took you minus 1, and notice you get the same answer. Okay, so a couple more examples. Probability that the bowler rolls a strike is 70%, so that is your P. Find the probability the bowler hits his first strike the 3rd time he tried. So probability of P is probability 3 is P comma X in your calculator using 65H. P is just 0.07, H is 3. So you would put it in and put P is 0.70, X is 3, and it will hit enter, and you get that answer. Okay, probability of hitting bullseye while you have a percentage of 36%, and you are on your 7th attempt. So probability of 7 is, again, menu 65H, or using the formula 0.36 times 1 minus 0.36 times 7 minus 1. So either one of those will give you the same answer of 0.025. So how do you know you're using a geometric versus a binomial? Well, notice that there's something missing in all of this. In binomial, you have your P, you have an N, and you have an X. In geometric, all you have is your P and your X. You don't get an N. So that's one clue as to I'm doing a geometric instead of binomial. But again, you are going to have success or failure. You're going to have independent. So every time the bowler bowls a ball, his result is independent of the previous bowls that he's made. But again, you only have a P or an X. So that's how you can tell, oh, I'm doing a geometric. Okay, the last one is Poisson. Poisson distribution is a discrete probability distribution. The experiment consists of counting the number of times an event occurs in a given interval, say of time, area, or volume. The probability event is the same for each of the intervals, and the number of occurrences in one interval is independent of the other occurrences. So this one's kind of screwy, but the idea is pretty simple, and it's got something very important in it. The formula is the mean raised to the x times e raised to the negative mean over x factorial. So here's where you're looking. Assume that mean bankruptcies filed per minute. So this is talking about time. In a recent year was about 2. So mean, our mu, that's actually supposed to be a mu signature. Mu is 2. And we want to find the probability of exactly x, 5. That's your x. So there's your two variables. So before with binomial, you had your n, your p, and your x. With geometric, you have your p and your x. With Poisson, it will always say the word mean. So you have mean and then the number of x's. So we find 2 to the 5th times e to the negative 2, because 2 is mean, over 5 factorial. And you get your answer. If you're using the calculator, the shortcut is 65A, mean 65J, excuse me. I keep using this funny looking upside down mu. I can't remember actually what it's called. It's another symbol for mean that's used in Poisson. So if you look at the Poisson formula, it's actually using this version instead of the mu. But mu is the same thing. Okay, that is all of the notes for